Hello children, welcome to K-Tech High School and Junior College. Blessings of grace and peace be with you today and every day. Make positive thoughts and enjoy every moment of this day. Wishing you all a very cheerful morning. So today children, we are going to start a new lesson. Current, electricity and magnetism. So let's begin. Do you recognize the person you see on the screen? Yes, he is the great Thomas Edison. Do you know for what he is known for? In 1879, he invented the first practical, long-lasting electric bulb. And since then, our home is even bright after the sunset. You must be aware of the fact that lights in a home works on electricity. However, they are not only one who use electricity. Our television, air conditioners, water heaters, fans and so on also need electricity to function. A laser light or even a small flashlight also works on electricity. Imagine a life without electricity in the world today. The discovery of electricity has helped to start a new revolution in the history of humankind. There are basically two types of electricity. One is the static electricity and the other is dynamic electricity. For now, we will learn about dynamic electricity. From the name itself, we can say that it implies moving electricity or more precisely moving electric charges. Now the next question you will have, what are electric charges? The concept of electric charges is very important and I shall try to give you a short and to the point explanation of this concept. So children, let's begin. There are two types of electric charges. Okay children? The positive denoted by plus sign and negative by minus sign. Think of a magnet for a moment. We know that two like poles, that is two north poles or two south poles of a magnet repel each other and unlike poles attract each other. Similarly, like charges, that is two positive or two negative ones, repel each other. And unlike charges, that is a positive and a negative one, attract each other. But what exactly is charge? Or in other words, who actually carries these charges? Well, these charges are carried by tiny particles with incredibly small mass. They are called as subatomic particles. The positive charges carried by the particles called protons, while negative ones are carried by the particles called electrons. There are billions and trillions of protons and electrons present in any object around us. In some objects like metals, electrons can move randomly. while in non-metals their position is a kind of fix and hence they cannot move freely. Now, any appliance in our house, for example a tube light, works because the negatively charged electrons are moving in the wire in one direction. This unidirectional motion of electrons in a wire is also called electric current. These wires are made up of metals, usually copper or aluminium. But why are the charges in the wire moving in one direction? Or what makes the charge move in a wire? The charges move in one direction in the wire because of the energy supplied to them by the transformers. So the transformers supplies energy to charges to move in a wire, which in turn makes the appliance work. A flashlight also works on the same way, but here the energy is supplied by two electric batteries. So sum it all up, children. Dynamic electricity is the flow of electric charges through conductors in one direction. Generally, when we talk about electricity or electric current, we mean dynamic electricity. Hence, we simply say that electricity is nothing but the flow of charge through a conductor. Got it, dear children? Imagine you have two beakers filled with equal amount of water and they are both connected to each other by a pipe at the bottom. If you observe the two beakers for a few seconds, do you think the water will flow from one to the other? No, you will see that the water in both the beakers are as it is and there is no flow of water. Now let me give you a task. Without changing the amount of water in any of the beakers, can you make the water from beaker 2 to beaker 1? Understand my question again. You need to flow water from beaker 2 to beaker 1, but you are not allowed to change the water from the beakers. So you cannot add or remove water from any of the beakers. How will you do it, children? You have to think a little. Okay, it's easy. One of the things you could do is raise the height of second beaker. Once it is raised at a height, the water will flow from beaker 2 to beaker 1. What exactly happened here? What was the factor that made the water flow? In simple terms, the factor was height. Yes, you can talk about the gravity or pressure difference. But in layman terms, it is the height difference that causes water to flow from the second beaker to the first. In an exactly the similar way, for electricity to flow, there has to be the same factor. We will come to that. Don't worry. So, if we just have a copper wire, do you think will the electricity flow through it? Clearly not, because there is nothing that is triggering it. There is no factor triggering it. So, what is the factor that triggers the flow of electricity? It is called the potential difference. Well, I can define this term in one line, but that wouldn't help you to understand the concept. So let's study deeper into it. We see the word potential here. Have you heard this term before? Of course, we have heard about potential energy. It is the stored energy when an object is at rest. When you hold a ball in your hand, it has a potential energy. When you drop it, the potential energy is getting converted to kinetic energy when it drops down to the ground. Kinetic energy is the energy when an object has when it is in motion. Similarly, there is a concept of electrical potential energy. The electric potential energy of any charge describes how much the stored energy it has. Just like the ball in your hand has high potential energy, and a negative charge close to another negative charge has high potential energy. If left free, the charge will be repelled by the negative charge and will move towards the positive charge, just like the ball will fall towards the earth. What's potential difference then? It's just the difference of electric pressure between 2 points, and this difference may arise from the battery consisting of a cell. Potential difference is also referred to a voltage. If we have to understand the technical definition, we would say that it is the work done to move a unit charge from one point to another. The potential difference V between 2 points in an electric current is equal to the work done over the charge. We know that work is measured in joules and charge is measured in coulombs. So what will be the SI unit of potential difference then? It's volt, named after Alessandro Volta, an Italian physicist. So how we will define volt in a current carrying conductor? It is the potential difference between any 2 points when 1 joule of work is done to move a charge of 1 coulomb from one point to another. The potential difference is measured by an instrument called voltmeter. It is measured in parallel across the point between which the potential difference is to be measured. Now let's see how to light up a 2.5 volt torch bulb using a 1.5 volt electric cell in an experiment. We simply have to connect the positive terminal of the cell with any one of the terminal of the bulb, and finally complete the circuit by connecting the negative terminal of the cell to the second terminal of the bulb. The bulb then glows. The word circuit is very important here. In this context, it will be an electric circuit. In simply words, it is the path along which electric current can flow. You can see here a closed loop is formed. All the terminals of the electric cells and bulbs are occupied. So here the electric current is flowing along the closed path. We say that the electric current is complete. But how exactly does the electricity flow through the circuit? It is difficult to understand. However, I will make it easy for you to understand this phenomena. Okay, children? Now, basically, it is said that electricity or electric current is the flow of electrons in one direction. What really happens is that the negative terminal of the cell repels the electrons in the copper wire near it. So, the electrons in the copper wire drift away from the terminals, but in the process they repel the neighboring electrons, or in other words, they transfer some of the energy to their neighboring electrons. So, the neighboring electrons are also pushed away. They in turn transfer the energy to their neighboring electrons. The process continues and energy flows throughout the circuit. This flow of electrical energy is nothing but the electric current. So these are the two ways to define electric current. But this one is more accurate of the two. In reality, electrons don't really travel from the negative terminal all the way to the positive terminal. The electrons merely drifts slightly from the rest position and transfer the energy to their neighbors. This is because the wire is a solid object and the density of an atom per unit volume is very high. Hence, there is no space available for electrons to travel all the way through. So it is this electrical energy to travel to this circuit. But how does the energy flow through the bulb? The electrons in a copper wire transfer this energy to the electrons in the metal rod connected to one of the terminals. This energy then flows through the rods, through the filaments and out from the second terminal. So in this way, the energy is transferred through a bulb. When the energy flows between the two of the filaments, it heats up the filament, which in turn glows and gives us light. I hope now it is clear how the electricity passes through a circuit. But for how long does the electricity keep flowing? The energy will flow as long as the circuit is connected or until the cell dies off. So we learned that electric circuit should be complete for the bulb to light up. But is this the only way for the circuit to complete? Well, if we interchange the wires connected to the two terminals of the bulb, then the circuit is still complete. So the bulb will still glow. Now look at this circuit. Is it complete? No, it isn't. Not only all the terminals of the systems are occupied, for instance, this terminal is not connected to the circuit. Here, both positive and negative terminals of the battery are connected to only one terminal of the bulb. So, what's happening here? The energy is flowing from the negative terminal of the cell directly to the positive terminal of the cell. Not only the bulb will glow, but it will even get worse. The battery might explode and may severely injure us. You should know you should never connect the positive and negative terminals directly. This heats up the wire quickly, and at the same time the battery also drains really fast. I hope you all understood this concept, children. Now let's take a look over the summary. What is electric current? A flow of charge from one place to another is called electric current. The unit is ampere, which is equal to flow of 1 coulomb per second. This is known as electric current. What is potential difference? Potential difference or voltage is the difference in electric potential energy per unit of charge measured at 2 points. The symbol for potential difference or voltage is V and the unit is volts. An instrument used to measure the potential difference is called a voltmeter. Now, connections in a circuit. Electrons flow from negative to positive. Therefore, a complete circuit must have wires that connect the negative pole of the energy source to the positive pole of the energy source. The circuit is established when there is a continuous path for electricity to travel from one end of the energy source to the other end. I hope you all have understood today's session. Now let's take a look over the notes. First, we will write the new words. Then we will write glossary, the scientific meanings of the word. Question number 1. Choose the correct option and fill in the blanks. Here also, the second question is match the following, where you need to match the two columns. Question number 3 we have state whether the following statements are true or false. Next question is define the following term, followed by question number 5. Answer the following. You need to answer the questions in brief. Okay, children? Maintain the notes properly and draw this diagram also. Next, the same answer in brief continued. Question number 6 we have distinguish between volts and amperes. So these are the notes you need to maintain in your science book. Thank you, my dear children. I hope you all have understood and enjoyed today's session. See you soon in the next one. Till then, take care. Bye-bye.